So welcome back to Level 1 Physics, looking at the mechanics external standard, and today looking at the difference between kinetic and potential energy. So when we talk about potential energy, essentially in Level 1, we look primarily at gravitational potential energy. And it's basically the energy that is stored when an object is moving upwards. Okay, so work is being done, energy is being transferred to move an object upwards, and the equation for gravitational potential energy, GPE, is the mass of that object times the gravitational field strength, which on Earth is around about 10 newtons per kilogram, times the height that the object is moving up. Okay, so GPE equals m times g times h, where because gravitational potential energy is an energy, it is measured in joules, mass is in kilograms. As discussed, the gravitational field strength, which differs depending what planet you're on, is in newtons per kilogram, and height is measured in meters. Okay, and the other kind of energy that we focus on in Level 1 is kinetic energy, the energy of movement. And the equation for kinetic energy is half times the mass times the speed of that object squared. So Ke equals half mv squared, where kinetic energy is of course measured in joules, mass again is in kilograms, and the speed v is measured in meters per second. So in terms of conservation of energy in a system, the total amount of energy is the same, but it's shared between the potential energy and the kinetic energy. So because we've been focusing on gravitational potential energy, that's what we'll look at in this particular slide. Okay, so if there's no air resistance, then you have conservation of energy. The total energy of the system stays the same. And that happens because the gravitational potential energy, as it moves from the height, is going to be all converted into kinetic energy at the bottom as that object falls in terms of its height. So the gain of kinetic energy will be equal to the loss of gravitational potential energy. So what does that look like? Well, at the top, all the energy is in gravitational potential energy, so you can calculate that by the ball's mass times the gravitational field strength times height. And because it's not moving, the kinetic energy is 0. Halfway through the fall, the gravitational potential energy will equal the kinetic energy, so the GPE equals half mgh, and therefore kinetic energy, of course, is going to be equal to half m1 squared, so mv1 squared, which is the v is the velocity at that point in time, halfway through its journey. And at the bottom, the gravitational potential energy will be equal to 0. The kinetic energy will be at a maximum, okay, half mv squared, and that means that the kinetic energy at the bottom will equal the mass times the gravity times the height, the potential energy of the ball at the start. So we plot that on a graph. You'll see right at the bottom corner there, the object is dropped, and the kinetic energy starts to increase as the gravitational potential energy decreases. Okay, so about halfway through, they'll equal each other, and at the bottom, you'll see that there'll be no more gravitational potential energy. It's all been converted into kinetic energy. So the total energy of the system will equal the gravitational potential energy plus the kinetic energy. Okay, so depending where it is in its journey, the ratio of GPE to KE will be different.